Let's discuss in this video a very important way of solving a differential equation. Okay. Now, there are three methods. Okay. Or you can say that there are three types, methods. You can call it however you want. All right. The first method of solving a differential equation, we call that as variable separable method. All right. Variable separable method. See, the name itself tells what we are going to do. You are going to separate the variables and then you are going to integrate them individually. Understood? So, as you are going to look at variable separable method, you are going to have dy by dx and then you are going to take dy and dx separately and you are going to do it. Okay, it's quite simple and quite direct. The second type or second method of solving is called as homogeneous method. So you have a function of xy, then you're going to take another parameter and you're going to do it. And the third type is called as linear differential equation. Now in linear differential equation, we are going to consider something called as an integral function, and with the help of that, we are going to solve the differential equation. Okay, so right now in this video, we are going to discuss and understand about this variable separable method. Homogeneous and linear, we are going to look at it later. So for now, variable separable method, a very important and a very easy method of finding the differential equation. Not finding, more like solving the differential equation. Fair enough. So what it is and how we are going to go about it, let's look at it. See, variable. So we have variable and separable method, correct? Separating the variable. Suppose, say, a very simple example I'll take. All right. Say you have x divided by y is equal to dy by dx. Say you have a differential equation something like this. Okay, or it became very direct, but that's okay. We are starting with level 1, or maybe level 0. See, x by y is equal to dy by dx. Now you can separate the dy and dx. Now generally what do we say in derivative? That dy and dx cannot be separated, correct? Because it's a function d by dx of y, isn't it? But according to differential equation, we can. What we do in this particular type of method of solving of differential equation is that we separate dy, we separate dx, and we have the y function and we have the x function, right? Or you can also say we have the y variable, we have the x variable. Separate the x and y variables. Make sense? So what we are going to do now is that separate x into dx is equal to y into dy. So basically what did we do? We took the y this side and we took the dx this side, correct? You separated the variables and now we can integrate the LHS and RHS. Okay, if you integrate integration of x dx, integration of y dy. Make sense? Now what do we get? X square by 2 y square by 2 plus c, correct? Or x square by 2 minus y square by 2 is c. Or you can just solve it as x square minus y square is equal to 2c, which is c dash. Anyway, the whole point of this example, what I gave, is just to understand this one. Just to understand that one. That is how you can take the dy and dx, separate it, take the variables, separate it, and then integrate individually. That is going to give you the variable separable method. I hope this is clear. So in general, suppose if you have dy by dx, all right, and then you have a function f of x comma y, Then what do we do? So sorry, integration, small letter f of x comma y. Then you can take f of y dy is equal to f of x dx. You need to understand, okay, so this is a variable separable method. Split it, get the answer done. Understood? So this method is what we call as variable separable method. Okay, I already showed you an example. See, this is a beautiful example to understand with. Now, in the next video, we'll start with very basic problems. Okay, then we'll move on to a little more higher level of problems. All right. So we are going to start with problems from the next video.